Welcome back to Old School Math. Today we're going to be talking about maximum and minimum values of a function. Now when we're talking about maximum and minimum values on a graph, we always want to be talking about the y values. Why the y values? Well, because the y values are the parts that go up and down, right? Our y-axis is our vertical axis. So it makes sense when we're talking maximum and minimum values that we're only interested in the y values. Now maxima are the places where the graph reaches a peak or the maximum value. And minima are the places where graphs reach a valley or the lower value there. The absolute maximum is the absolute highest place on a graph or the highest value of a function. Note that not every function will have an absolute maximum, as the values may increase forever to infinity. So if we look at x squared, for example, that's a graph where you would see the function increasing on both sides to the left and to the right, up forever. So since these two sides keep going up, there's no absolute maximum value that they'll reach, right? They never top out or peak out. If we look at negative x squared, it does have a maximum value. So that negative x squared looks something kind of like this. And the absolute maximum value that it will reach would be a y value of 0. The absolute minimum value is the absolute lowest place on a graph, or the lowest value of a function. Not every function, again, will have a minimum value, as the values may decrease forever to negative infinity. If we look at an example, the square root of x, that graph looks something kind of like this. This does have an absolute minimum value. Again, that lives at 0. The graph value does not, or the y value of the graph, or the function value, never gets lower than 0. If we look at the cube root of x, it's going to look something kind of like this. Now we see this graph rising a little bit to the right and falling a little bit to the left. And even though it's not decreasing by much here, it continues to decrease. And it decreases forever. So we would say that goes to negative infinity. We would say this has no absolute min. And likewise, it has no absolute max because this side keeps increasing forever. Now let's talk about relative maximum and minimum. This is a little bit different than the absolute because a function could have no absolute max or min, but have relative maxima and minima. A relative max or min is different from your absolute. It's simply just a turning point in the graph, or where the function values change from decreasing to increasing or from increasing to decreasing. So if we look here at this little, I don't know, maybe we've got a fun little polynomial in here, right? We see that this has no absolute maximum value because this side continues to increase to infinity. This side decreases forever to negative infinity. But right here and right here on the graph, we have something interesting. So these are what we call relative max and mins, or local maximum and minimums. And the reason that we call them local is because in this area of the graph, it's the highest point. In this area of the graph over here, this value is the lowest point. So let's take a look at this example together. I'm going to graph this in my graphing calculator. Let's go to x cubed. Let's do this. X to the third power minus 3x squared. Whoops, that's all in the exponent. X to the third, and let's get out of the exponent now. 3x squared. Pay attention to what you're doing. And we see, whoa, I don't know that I put that in right. Yep, I just did something funny there. All right. Again, pay attention to what you're doing. That's more a note for me than for you. All right, here we go. That's the graph that I was wanting to see. So we see two different turning points in this graph, right? Now this is a polynomial function. We'll talk more about them later on this year. But we see we have a relative maximum here at 0 at the point 0, 0. And we also have a relative minimum down here at this point. That's the point 2, negative 4. So the relative minimum there is negative 4. Now, this doesn't tell us anything other than that's where the graph goes from increasing to decreasing or from decreasing to increasing. So that's a turning point on the graph. It's not the absolute highest value because we see the y value gets much higher than 0, and the minimum y value gets much lower than negative 4. In fact, it continues to positive infinity and negative infinity. Now, we can also do this stuff in the calculator. So if I wanted to figure out what this is exactly in the calculator, there's a simple process to go through here. So first we want to do is type our function in y equals and graph it. Once we have our graph made, we'll click second and then this trace button right here next to graph. And this brings up a menu of calculations that we can do in the graph. So depending on whether we want to do a maximum or a minimum, we'll select either option 3 or 4. I want to do that minimum. So I'm going to choose option 3. And you see a blinking cursor come up on the graph. You can move that cursor left and right with the left and right arrow keys on the keypad. I always try and get it to the minimum value or pretty close to it. And this tells me down here that it's the cursor sitting at 1.969697, and the y value of that cursor is negative 3.997273. But I want to find the exact value. So it prompts me to go left bound. So I'm going to take that cursor and move it to the left several times. Just hit that left button. It tells me to go right bound, so I'm going to go back to the minimum value and move to the right several times and hit enter. Then it asks me to guess. Guess right where that is, and I'm going to guess right there. It doesn't have to be perfect, but get pretty close. And hit enter one more time. We see something interesting happen here. We get an x value of 1.9999997 and a y value of negative 4. Anytime you do this on a calculator and you get some repeated decimal here, like all these nines, that's really just going to be a value of 2. Your calculator just doesn't know to round it to 2. And it's not a rounding issue in the calculator. The value is actually 2. It just, when it's doing its calculation, it gives that value there. And that's because of the pixels on the graph. It has nothing to do with, and the algorithm that it used to calculate that. It has nothing to do with that needing to be rounded. It is actually at 2, negative 4. So our minimum value there, or our relative minimum, is at negative 4. Let's do these couple examples together in the calculator too. So let's clear this out. Let's do the absolute value of x minus 2 plus 3. To go to absolute value, go to math, and then number, and then abs. Yeah, that's not your working out abs. That's your absolute value. X minus 2, and then plus 3. And let's graph that thing. And so we see it's going to live around here. If I look at the graph, it looks about like 2, 3. Let's check that it is. Second trace, that's a minimum value, so we're going to choose option 3. Let's move our cursor to the minimum value there, or close to it. Let's go left bound a couple times. Let's go back to that minimum value, right bound a couple times, and hit enter. And then back to that minimum value, hit enter. And again, it gives you something with a bunch of zeros and then a 7, and then a 3 with a bunch of zeros and a 7. This is one of those instances where all those zeros don't really matter. It's just 2, 3. And with our transformations on this, we should know that that would be right. So if we look at this, 2, 3 is where our vertex of this absolute value lives. So that minimum value, the absolute minimum we would say is at 3. That's our minimum y value for this function. If we look at this next one, let's put some parentheses, x minus 1 to the third power. Get out of the exponent now, do minus 4. And we get a function that looks kind of like this. Maybe that's a bad sketch on my graph, but I wanted to do it quickly. We see here that the right side and the left side both continue going up and down forever. And there's no true turning point in here. It just kind of slows down and then goes back up. So there's no absolute max or min. And there's no relative max or min, okay? And that is perfectly fine. Not all graphs will have a relative or an absolute max or min. For our square root of x plus 2 quantity plus 3, we can look at it. Square root is going to be second and then this x squared button. So we're going to do our x plus 2. That's the wrong x. That x plus 2. Get out of the parentheses and then do your plus 3. Hit graph. And we'll see that the graph stops right here. So this would tell me that I have an absolute minimum value right there. Our transformations would tell us that is at negative 2, 3. So the minimum value, and on this one, it would be hard to go left bound to that, but we can also find that on the table. So if we click second and then table, we see we get all these negative values for x have an error. That's because we aren't supposed to put a negative value under a square root. But when we put negative 2 under the square root, it evaluates to the y value of 3. So that 3 is our absolute minimum. Okay? Let's look at this one here. Cube root. To get to a cube root, go to math and then go down to option 4. That'll give you a cube root of x plus 5. Get out of the cube root there, and then we've got a minus 4. So when we look at this graph, again, we see this graph continuing to increase to the right forever. It continues to decrease to the left forever. That means there is no absolute max or min. There's also no relative max or min. Okay? So that's perfectly fine for that to happen. No absolute and no relative max or min for your graphs. I've got a little bit of practice on this next page for you. I have some graphs for you to look at your relative and local, or relative and absolute maximum and minimum values. And then I have some functions that I want you to graph on that first page and on that second page. And again, if there's no absolute or relative max and min, you can just write NA. So on this first one here, we've got 2 times the square root of x plus 3, and then minus 4. And so this graph here looks a lot like this graph here. I can tell that I have a absolute minimum value at negative 4. And there's no absolute value. There's no absolute maximum value, so I'm going to put NA. There's also no turning point, so our relative minimum and our relative maximum aren't really going to be applicable here either, right? So the only thing that we have on this graph in terms of our max and mins is an absolute minimum value at negative 4. There's no absolute maximum value, again, because it increases forever. Okay? So I'm going to let y'all do your practice. Let me know if you have questions. Be happy to help you out. And as always, thanks for watching.